Day 162, Honors Physics, Photoelectric Effect, homework problem number 26. Once again, I have the problem laid out numerically, the steps 1, 2, 3, and 4, and 5 in blue. I've taken the shortcut again over here, upper right. Combining these two equations, you get the energy of a photon is Planck's constant times its velocity divided by its wavelength. I'm going to start off everything in joules here. I think that'll be easier, at least initially. The joule version of Planck's constant times the velocity of a photon, as always, divided by the given wavelength. And you do have to kind of, well, make sure you read the problem. It says, if you go back and read this, it says green light of wavelength 550 nanometers is hitting an electrode, a metal electrode, producing electrons that have a speed. So this green light coming in is not the work function, it's not the threshold, it's above the threshold because it's emitting electrons with a velocity. So this green light they're talking about here is this energy incoming, hitting the metal surface. And so over here on the right then, this energy is the energy of those green photons. And I also know the velocity of the emitted electrons and the mass as 9.11 times 10 to the negative 31st. So then I can calculate the kinetic energy of the photo-emitted electrons. So those two numbers, or those two values, this is a little bit backwards. Well, this goes over here for E, the energy of the incoming, and this will be the Ke max for the photo-emitted electrons. That leaves me with the unknown work function right here. Once I plug those two numbers in, that number and this number, so I can again calculate the work function in joules for this surface. And then using this conversion down here on the bottom right, 1 electron volt is 1.6 times 10 to the negative 19th joules. I can get the work function in electron volts. That would be the answer to part A of this problem. I guess I could have put that there. I'll do it now. That's the answer to part A. All right, then once I have that, I'm going to find the wavelength of that particular energy, a photon, if a photon had that energy, because once again, at the threshold, we're talking about the wavelength, the work function, the wavelength of those photons that would have that energy, the frequency of the photons that would have that energy, they're all at that energy level. So without using the shortcut this time, the energy of those photons is H times F. So you would plug this energy in for E, and make sure now if you're in electron volts, you want to use the electron volt version of Planck's constant, the 4.14 times 10 to the negative 15th for the H value here. That would give you then the frequency in hertz that you would plug into F right here. And then the velocity is still the velocity of a photon, 3.00 times 10 to the 8th, so you know this number. So 3.00 times 10 to the 8th divided by this frequency would give you the wavelength of these photoelectric threshold photons.